SpaceX and their Falcon Heavy is gearing up for a thrilling mission they've never attempted before. In the summer, SpaceX is expected to embark on a monumental mission that will attempt to land both Falcon Heavy's boosters on two separate drone ships simultaneously. Today, we'll explore the intricate plans that SpaceX has laid out to conquer this formidable challenge and the far-reaching implications this triumphant achievement will hold for the future of the Falcon Heavy. Before we begin, let's discuss how SpaceX manages to land these boosters again and again. The landing of Falcon Heavy boosters are a result of meticulous planning, cutting-edge technology, extensive testing, and a highly skilled team. Their unique propulsive landing technique allows the boosters to reignite their engines after separating from the rocket's core stage and execute complex maneuvers for a controlled descent, enabling vertical landings on designated pads or ships. Equipped with advanced guidance, navigation, and control systems, the boosters meticulously monitor and adjust their position, velocity, and orientation in real time, ensuring pinpoint accuracy during the landing process. Furthermore, the landing process is highly automated, minimizing human intervention. Falcon Heavy boosters are designed to autonomously execute necessary maneuvers and adjustments guided by onboard systems. This high degree of automation ensures consistent and precise landing performance. The Falcon Heavy has a remarkable track record of successful booster landings both on land and at sea. When it comes to sea landings, SpaceX relies on its fleet of autonomous drone ships for the crucial task of recovery operations. These autonomous spaceport drone ships are specially designed ocean-going vessels. They are derived from deck barges, equipped with powerful station-keeping engines, and feature a spacious landing platform. Once in position, these ships operate autonomously, meticulously controlling the landing process. SpaceX commissioned the construction of these remarkable ships to enable the recovery of launch vehicle first stages at sea. This is particularly important for missions where the spacecraft doesn't carry enough fuel to return to the launch site after successfully propelling the payload onto an orbital or interplanetary trajectory. Currently, SpaceX operates 3 operational drone ships. Just Read the Instructions and A Shortfall of Gravitas are deployed in the Atlantic Ocean to support launches from Kennedy Space Center and Cape Canaveral Space Force Station. Meanwhile, Of Course I Still Love You operates in the Pacific Ocean, assisting missions from Vandenberg Space Force Base. These autonomous spaceport drone ships are a vital component in SpaceX's mission to revolutionize space launch services. By achieving full and rapid reusability, SpaceX aims to significantly reduce the cost of space launches. The development of these ships was a crucial part of the company's long-term reusable rocket program. The Falcon Heavy, as the highly adaptable craft the rocket is, can be configured to land at sea, on land, or even expend the first stage, depending on the specific requirements of the mission. Flights of the Falcon Heavy destined for geostationary orbit or surpassing escape velocity necessitate sea landings. These missions constitute the majority of the rocket's endeavors. Furthermore, the rocket's configuration can be customized to accommodate different payloads, ensuring optimal performance for each mission. In the most recent Falcon Heavy mission, SpaceX decided to launch with no landing gears on board as the rocket carried the Viasat-3 Americas satellite into orbit. We have a video specifically about this launch on our channel if you'd like to know more about this Viasat-3 Americas mission. The Falcon Heavy has never before embarked on a daring mission to simultaneously land 2 boosters on autonomous drone ships. But now, that audacious feat is about to become a reality. Confirmation of this exciting attempt came after an exchange between SpaceX and the Federal Communications Commission. The FCC was approached to authorize launch vehicle communications and 2 experimental first-stage drone ship recovery operations for SpaceX Falcon Heavy Mission 1468, scheduled to launch from Complex 39A at the Kennedy Space Center. This mission will involve 3 suborbital first-stage boosters and an orbital second stage. The purpose of the operation, as stated in the application, is to establish launch vehicle communications for a mission launching from LC-39A at the Kennedy Space Center, while also executing the drone ship recovery of 2 side core boosters. However, the center stage of the rocket will not be recovered and will instead be intentionally ditched into the water. With this communication now confirmed, SpaceX is on the verge of attempting an unprecedented simultaneous drone landing. Excitement and anticipation fill the air as SpaceX prepares to push the boundaries of space exploration once again. The stage is set for an extraordinary display of engineering prowess and innovation. Will they succeed in this daring endeavor? Only time will tell. What are your thoughts? Comment down below. The Falcon Heavy is one of the most powerful heavy lift launch vehicles on the planet. It has the ability to carry 64 metric tons of cargo into deep space, a feat that is even more astonishing when we consider it is the only reusable vehicle in existence in this category. The rocket has been a tremendous workhorse for SpaceX and has allowed the company to stay ahead of the competition, thanks to its comparatively cheaper launch costs. It promises to be an exciting year for the Falcon Heavy as SpaceX plans to use the vehicle 5 times in 2023, the most ever attempted by the company. While on paper, this dual booster landing may appear to be just another routine task for SpaceX, the reality is far from it. In fact, the Falcon Heavy has never managed to successfully retrieve its center core on a drone ship. Throughout its operational history, the Falcon Heavy has made a mere 3 attempts at landing on a drone ship. Unfortunately, 2 of those attempts resulted in the core missing the platform entirely, plunging into the depths of the ocean. The remaining attempt saw the core make contact with the drone ship, only to tip over and explode in a dramatic fashion. Nevertheless, it's crucial to note that these endeavors took place over 4 years ago, and SpaceX has evolved significantly since then. The company has amassed an impressive wealth of experience and has established a solid track record. If they triumph in this endeavor, it will undoubtedly propel the Falcon Heavy to unprecedented heights, opening up a multitude of exciting new opportunities for this remarkable rocket. The stage is set for a defining moment in SpaceX's history. All eyes are on the Falcon Heavy as it aims to overcome past challenges and demonstrate its remarkable capabilities. Will this mission mark a turning point for the Falcon Heavy's legacy? Adding to an intriguing launch, the rocket will carry the largest commercial satellite ever constructed, the Jupiter 3. This remarkable K-band satellite features a multi-spot beam design and is built upon a highly reliable space-proven platform. Harnessing advanced architecture and technological breakthroughs, the Jupiter 3 achieves an astounding throughput of 500 gigabytes per second specifically for North and South America. While the industry tends to focus on smaller satellites, the Jupiter 3 serves as a reminder of the pivotal role large spacecraft play in specific applications. Weighing approximately 20,300 pounds, 9,200 kilograms, the Jupiter 3 falls within the payload capacity of the Falcon Heavy, even considering the weight constraints for a geostationary orbit mission. It's about the size of a standard school bus when its antennas and solar panels are stowed. Adrian Morris, the executive vice president of Hughes Network Systems, confirms the satellite's ability to concentrate its entire bandwidth in a specific region when needed. This capability further highlights its efficiency and flexibility. Reaching a geostationary orbit necessitates a substantial amount of propellant to position the rocket with precision for deployment. However, this strategic deployment grants significant advantages to the Jupiter 3. By remaining stationary in orbit, it maintains a constant perspective of the Earth, thus enhancing the quality of its bandwidth coverage. With the Falcon Heavies ready for liftoff, the Jupiter 3 stands at the forefront of revolutionizing satellite communications, pushing the boundaries of connectivity to new horizons. In 2017, EchoStar, the parent company of Hughes, placed an order with Maxar for the Jupiter 3 satellite. Originally slated for a 2021 launch, the manufacturing process experienced significant delays, primarily due to the impact of the COVID-19 pandemic and extensive non-recurring engineering work. To address these delays, Maxar and EchoStar reached an amended contract in November 2022, with Maxar providing compensation for the extended timeline. The demand for data and high-speed connectivity has been on the rise, driven by individuals working and studying from home as well as the reliance on e-commerce for deliveries. To support this endeavor, Hughes has established a robust ground network specifically designed for the Jupiter 3 mission. SpaceX faces the pressure of delivering this critical hardware into orbit, and a successful mission will further solidify the Falcon Heavy's reputation as the most reliable and consistent heavy launch vehicle in the world. The launch is scheduled for August, and until then, we eagerly await another potential milestone achievement for SpaceX. Will they triumph or encounter challenges reminiscent of the last Starship test flight? Only time will reveal the outcome. Share your thoughts in the comments below as we anticipate this monumental launch mission.